Hello everyone, my name is Jonah Hinchin. So for our project for Calculus 2, I will be doing integration by parts. And so let's get started. Anyways, so one thing to remember that for every single differentiable rule, there's also a corresponding integration rule. So with that in mind, a product rule, actually its corresponding rule is the integration by parts. So by starting with the product rule formula, as you can see, the derivative of f of x times g of x equals f prime of x times g of x plus g prime of x times f of x. All right. So then what you simply do is you add integrals. You integrate it. So we get f of x g of x equals the integral of f prime of x g of x plus the integral, goodness sakes, of g prime of x f of x. Then simply to get our integration by parts formula, you just do a little rearranging. So here is our formula. This is what we should remember. The integral of f of x times g prime of x is equal to f of x times g of x minus the integral of f prime of x, g of x, dx. And that is the formula really to remember to simplify it, and as will be applied over, you use kind of a variation of u substitution for this. It can be simply understood as the integral of u dv equals uv minus the integral of v du. All right. Now one thing also to remember, get this erased here. I'll keep this formula up for a little bit longer, but I will eventually erase it, so please do get it down while it's up. It's very important to understand L-I-A-T-E. I like to call it liat. And so basically we have L-I-A-T-E. And that basically tells you, because when you say, okay, I have these two formulas, for example, which one's U, which one's V, having to figure that out, this is what tells you what to do. L is standing for all right. I, that is inverse. So inverse trig. All right. A, that is algebra. T is just normal trigonometry, or at least not inverse trig, I should say. And then finally, the last one is exponential. All right, so I'm gonna try and keep this up throughout the rest of the presentation. If it does get in my way, I'll erase it, but at the very least, get it down now, and then hopefully we won't have to worry about that later. All right, so I wanna give you some examples. There's several different variations. First, I'm just gonna give you two very basic, straightforward examples of integration by parts. Then I'll give you a third example where it's within a definite integral. So two indefinite integrals where we don't have to worry about a range and then a range. So you will get an actual result, a number at the end. And then finally we'll do a double, what's called a double integration by parts. T e to the negative 3t dt. Now people look at that and they go, oh no, t. Nah, it's just different instead of x. It's just basically another variable. So looking at this now, u is t, algebra. Versus an exponent, so that's dv, so that's e to the negative 3t, okay? Then, with that in mind, du becomes dt, and v, so the integral of e to the negative 3t is a negative 1/3 e to the negative 3t. You can read that. All right, forgive my handwriting, but negative 1/3 e to the negative 3t. All right, and then, once again, we'll plug it right into our equation, pretty straightforward. So the integral of te to the negative 3t is equal to u, just t at times v. So just to get things combined right away, negative t over 3, okay? E to the negative 3t, okay? Then it becomes minus, and once again, I'm just gonna go right in and incorporate the minus signs right away. So then we get plus the integral, let me see here, plus the integral, I should say plus the 1/3 integral. I'm taking that 1/3 out from here, that negative 1/3, and applying that. Let's see here, e to the negative 3t dt. All right, and then for you simply just apply. So All right, so we get equals to a negative 1/3 te to the negative 3t plus 1/3 times e to the negative 3t, let's see here, over 3, and this is actually negative, I apologize for not getting that in. Then, to simplify it, there's also, of course, going to be this plus c going on over here. To simplify it, you can simply apply this, and it becomes a negative 1/9 e to the negative 3t plus c, getting us our answer. There you guys go. I'll give you just a second to fill that in. All right, now we're switching gears just slightly. It'll still only be a single integration by parts. In fact, I'm gonna warn you guys now for the double integration by parts, there's a lot of space. So I will be erasing all of this stuff, okay? So please make sure you have that in your notes and or memorized. Anyways, okay, so we a definite integral with integration by parts. So we have the integral from 1/2 to 0 of x times cosine pi x dx. All right, pretty straightforward. So we go through with that, and because we have a trigonomic function versus an algebraic, it becomes x dx and cosine pi x, and of course within that, that'll affect its integral, and it becomes 1/pi sine pi x. All right, actually this is dx, there we go, whoops. All right, so with that in mind, we start plugging it in. Now what's really beautiful about this is that it is almost exactly like before, there's just an added step at the end. Let's see, I'm just gonna write the answer. So you get the integral of x cosine pi x dx is equal to, all right, so what you do is you go in and you apply, so, 1/2 to 0. So what you do is you go in and you apply, but whatever you do, you apply within the range. So for example, the formula will be, we're gonna do this, x over 1 times pi sine pi x, okay? Right? And that will be from 1/2 to 0, all right? Then you have the second part, which is still an integral form, so from 1/2 to 0, and it becomes 1/pi sine, let's see here, yep, you can still see that, pi x, all right? It's kind of getting to the edge there, get cutting close. Anyways, then simply what you do is you take the integral of this, and then you simply apply. So just, you get everything is equal to 1/2pi, all right? Sine pi over 2, all right? Then minus 0, because when 0 is applied through, it cancels out. Minus, and then take the integral. Well, what's really neat is when you take this integral, you can take that 1/pi out, actually, and that just makes life a whole lot simpler, okay? Makes life great. We love it. And you basically get times negative 1/pi cosine pi x, and then that's within the range still of 1/2 to 0 that you need to apply. So then the next step, we're going to plug in this last section. So we have cosine, we'll basically end up with cosine of pi over 2 and cosine of 0. So cosine of pi over 2 is 0, and then cosine of 0 is actually 1. So with that in mind, what we end up getting as our final answer is 1/2pi plus 1/pi squared. Actually, I apologize, there is one mistake, I'm so sorry, don't know if I'm allowed to say this, but this is actually minus. So just to walk you through that quick, negative 1/pi times this negative 1, which you would have been able to take out, and it becomes 1/pi squared positive. Then this basically becomes 0 minus 1 once you apply the range. And when that happens, it once again, -1 times that +1 over pi squared, making it that. So here is our final answer. Please get that down. I apologize for the glare. That's really unfortunate. It is 1 over 2 pi minus 1 over pi squared. All right, guys, last one. The integral of e to the 7x cosine 2x dx. All right, so you go through and we have u is equal to cos 2x du is equal to -2 sine 2x dv is equal to e to the 7x, and v is equal to 1/7 e to the 7th x. All right, so now applying our formula, we get 1/7 e to the 7x cosine 2x, and then 2/7 integral e to the 7x sine 2x dx. All right, so if you look, we have once again an f of x and a g of x, so then we have to do that again. So now down here we have, so we're going to take this once again, so 1/7 e to the 7x cosine 2x, right, plus, now we have to remember this is all times 2/7 times, and many people might go, now what we're going to do is actually first we're going to put this through. All right, but as you can probably already tell, we're like, wait a second, we're kind of back where we started. Like, how does that work? I will show you. All right, so, and basically, actually what I'll do simply is go like this, because what you do is you just distribute that 2/7, and you get, sorry, you get 2 over 49, and then 4 over 49. So, with that in mind, you then go, wait a second, yeah, that is exactly what we're going for, so what are we supposed to do? Well, remember, this entire problem is still equal to the integral of e to the 7x cosine 2x, all right? With that in mind, what you do is, we want to get rid of that. So, with that in mind, what you do is you multiply both sides. Multiply this side over here by 49 over 49. So you're basically multiplying it by 0. I mean, not 0, 1. And then with that in mind, you simply add this over. So, taking it up here, you are now basically given, let's see here, you get 53 over 49 integral of e to the 7x cos 2x dx is equal to, is equal to 1/7 e to the 7x cos 2x, taking that from here, all right, plus 2 over 49 e to the 7x sine 2x, all right? So now we have that all taken care of, but then we go, wait a second, we didn't want to have this, we're looking for this. So you have to then multiply each by its inverse, so it becomes 49 over 53, and then you multiply, of course, this whole thing by 49 over 53. And in short, what you end up getting, and I will erase so that we have a grand area for our final answer, we get equals to 7 over 53 e to the 7x cosine 2x plus 2 over 53 e to the 7x sine 2x. And then, of course, remember, it's an indefinite integral, so you have to add that c. And that, my friends, is our answer. All right, folks, thank you so much.